So first, let's just make sure we're all on the same page. And I'm sure most of you are like, well, we already know what machine vision is, Ryan. Why are you bothering this? Well, because I like to make sure that we're all on the same page of understanding what we consider to be machine vision. And there's a lot of definitions out there, but I really like a very succinct, easy way to define something. So my favorite definition of machine vision is the automated extraction of useful information from digital images. That's it. It's simple, right? We take a picture and we get some sort of information out of it to do something. That's all it is. We have 3 steps to it, right? Image acquisition, image analysis, and data processing. Now, how that translates into life sciences can be a little interesting, right? I don't want to get all preachy here, but oftentimes when we use machine vision in life sciences, we're actually using our technology to help make the world a better place to live, to improve the lives of people in it. And this isn't just something I say to use some buzzwords about making the world a better place, but it also is true. With machine vision in life sciences, we can help doctors and researchers and lab techs learn more from images of and data than they have in the past. So one example we'll actually talk about later, which is a great showcase of this, is in the microscopy field. We can use machine vision to predetermine whether or not a cell is cancerous before it even could get to a doctor to look at. And what that does is that helps filter out bad tests, for instance, and it helps make the time of our extremely expertised professionals more useful, right? We're not wasting time of these doctors and researchers because we can do this with our products. So how does machine vision work? Machine vision, it's really important to know, is not a single product. Here at Omron, we sell a lot of machine vision products, right? We sell cameras, we sell IPCs, we've got lights, we've got lensing, and we've got software, but we wouldn't call one of those individually machine vision. Machine vision is a conglomeration of all those technologies being used together. In order to have machine vision, you have to have a camera. This can be a smart camera like our FHV7 or our F430 Microhawk system, or this can be an industrial camera like our Omron Centec GigiVision line, for instance. And then you need to be able to process. This can be done on an FH controller, an IPC, an HMI, a multitude of products that's actually holding the software and doing those processes we need done for machine vision. In the case of a smart camera like FHV7, of course, that's being done on board, which is taking less stress away from the designer, right? Then we need to have optics. You can't have a camera without a lens. It's the #1 rule. And lighting, right? If you talk to most vision engineers, one of the things they'll tell you is the most difficult and the most detailed part of machine vision is always lighting. Most of the problems that we've got with machine vision, we can solve with lights. Do you have the proper contrast? Is your ambient lighting okay? All of this is important in putting together a machine vision solution. And lastly, you have to have the software. All of this that we've put together is not very useful unless we have a software to actually process the image data that we're producing. Softwares can range anything from Omron's AutoVision platform to, for instance, the FC Panda series with our FH, and they all can do different things, right? We might have one software that's really good at doing a specific task that we want to use over and over again, right? I don't want to go through this too much in detail. Everyone will have access to this presentation later, but this is just a really great example of how machine vision is truly set up. And it really goes into these 3 steps, right? We have capture. We can see a camera with a lens using light to take an image from a scene. Process, that data is being sent over to some sort of processor that's actually starting to make that data into something useful. And then we have analyze. The software is actually starting to do a task. So if we're taking a picture of a slide of cells, process that image, and then we're analyzing to say which cells are healthy and which cells are not. Very simple way to look at it. So what are some common machine vision solutions we see today? And there are tons of them. We could have a 2-hour presentation of me just literally listing off applications for machine visions in life sciences. Nobody wants that, right? Excel sheets, that's what those are for. But 3 of the big ones we really want to focus on are quality control, data accuracy, and traceability. And when we talk about traceability for machine vision, mostly we are talking about, of course, that image part, right? Traceability is such a huge term for multiple different products working together for these life science companies. But when we talk about traceability with machine vision, we're talking a lot about barcode reading, label verification, and that sort of thing.